Welcome to the 8th session of Electromagnetic Theory and Interference course. Let us continue the vector calculus in this session. So last session we discussed about the vector differential operator, that is del operator, which is used for finding the gradient of a scalar field and divergence of a vector field. Now let us see two more operations that can be done using del operator, that is curl and Laplacian, and solve the problem in each of them. So coming to the curl operator, it is nothing but a del cross a vector. Okay, where curl of A means del cross A vector. So actually, why we are finding the curl of a vector field? It is helpful for finding the rotational property of a particular field. Okay, the circulation or the rotation per unit area at a point within the field I can find. If you think of if you stir a coffee, okay, the curl represents the swirling motion in the fluid. I hope you understood the meaning of curl here from this simple example. So how you define the del cross A vector? We already know the del operator is equal to dou by dou x into ax cap plus dou by dou y into ay cap plus dou by dou z into az cap. And we know how to write a vector in Cartesian coordinates. So we have to club these two and we have to write the cross product. We know a cross product can be written in a determinant form. So first row I have to write the unit vectors. Second row I have to write the differential, partial differential parts, dou by dou x, dou by dou y and dou by dou z. So this is the first operation, right? Del. So that I have written in the second row. And in the third row I have to fill the components of the vector along each of the axes. Okay, so how will I expand the determinant? Let us see. First, I have to take the unit vector outside A. First, this particular unit vector I am taking. So I am leaving this particular column and row. What I have to do, I have to cross multiply dou Az by dou y, and I have to put a negative sign. And what is left? Dou Ay by dou Az. For the next term, I can write in two ways. Let us see the conventional way. What we will do usually, you will put a negative sign for the next term. This positive. We will see how it got changed to positive. We will put a negative sign, write the second unit vector A by cap, and we have to leave that particular column and row. And what is left? We have to write dou A Z by dou x first minus dou Ax by dou Z. Able to understand. Then for the last term, I have to write the plus Az unit vector. Then I have to leave this particular row and this particular column. And what is left now? I have to cross multiply the unit vectors. Dou Ay by dou x minus dou Ax by dou y. So what they have done is they have multiplied within the minus symbol, and this minus and minus turns out to plus, and this ax term comes before, and since because of this single minus, this az term comes next. So I can write in two ways also. So hope you understood how to find a curl of a vector. Okay, and the curl of a vector field, what is the result here? I will get the say vector only as a output. Please understand, the curl of a vector is a vector because we have the unit vectors coming in the resultant expression. Similarly, we can write the curl of a vector in other two coordinate system, that is cylindrical and spherical. We will see how to do this in a separate session later. So consider at this point. Okay, the curl at point P. Okay, it is a having some rotational property, right? So it is rotating. Whereas here the vector field is moving across. There is no rotational property of a curl. So curl at this point is 0. Okay, when a curl of a vector will be 0, see this curl of a vector is 0. When my vector field is irrotational, it doesn't have a rotational property, means curl will be 0. One more thing you to notice, curl of a gradient of a scalar field. We know curl is del cross. Gradient of a scalar means del is the gradient operator, V is the scalar quantity that I already mentioned. That is equal to 0. Curl of a scalar field is always 0. So hope you understood the meaning of irrotational property. Okay, and the curl of a gradient of a scalar field. Let us see how to find the curl of a given vector field. In the previous session, we have been given a vector p, and we are using the same question here. Given a vector p, and we are asked to find the divergence, right? Because curl and divergence can be found for only a vector quantity. So now we are using the same question, and we are going to find the curl of a vector. So how will I write a vector in Cartesian? It is px into ax cap plus py into ay cap plus pz into az cap. So from the given expression, you can write what is px, what is py, and what is pz. Okay. So the unit vector here. So leave that and write x square yz for px. And here for ay component is not present, so it is 0, py is 0, and for this component pz is xz. So we know how to write a curl of a vector. Okay, we have to write the unit vector across the first row. Second row is the partial differentiation, and third row is my elements. Here you just replace this ax, y, px, py, and pz. Okay, this is general notation. So now you know how to expand the determinant that we saw. So you substitute the value pz with respect to, differentiate with respect to y partially. What will be my answer? There is no y term, so it turns out to be 0. Whereas in py already it is 0, so I can fill it 0 itself into ax cap. So this term get cancelled. Okay, whereas px is differentiated with respect to z, partially differentiated with respect to z means x square y term only will come. Okay, then pz divided by dx means I will get only z term. So this is the term we got here, and we have to multiply with ay cap. Then the last term py divided by dou x, dou py divided by dou x. My answer is py itself all 0, so this turns out to be 0. And here px divided by dou y, dou px divided by dou y means x square z will come. Okay, followed by the unit vector. So now I think we can just write only the terms that are left behind. Okay, x square y minus z into ay cap minus. So here one plus is there and one minus. So minus x square z into az cap. This is my curl of a given vector. So now let us see the next operator, that is Laplacian operator, which operates on a, we are going to see only the scalar version of it. Okay, that means I can find the we are going to see about del square v. Okay, what does a Laplacian operator will help us to understand? It describes the how much the scalar field is concentrated at a given point. Okay, how much the concentration of scalar field it is going to describe. So Laplacian of a scalar field, as I told, it is written as del square v. I can say it in other words that it is a divergence. This is a divergence, right? This is a divergence of a gradient of v. Okay, so del square v. Divergence, we know the formula for del, write it, and we know the formula for gradient. Okay, that entire v we have to take and partially differentiate and put the unit vector. This we know. So if we dot product this, see the multiplication of these terms will give me 9 expressions, out of which the 6 will go off. Okay, out of which 6 will go off, only 3 will be left. How? Because you know the dot product of same unit vector only I will get the answer. So only this terms will come, that is dou square v, already dou is there, so another dou square v by dou x square term will be there, plus dou square v by dou y square will be there, plus dou square v by dou z square. What is the result here? The input is a scalar as well as my output is also a scalar quantity. Okay. Now these are the other two Laplacian operators in other two coordinate systems. Let us see this later. And when my Laplacian will be 0, if my scalar field is harmonic in nature, my Laplacian, that is del square v, will be 0. That is Laplacian will vanish. There will be no. How to find the Laplacian of a given scalar field. Here in this problem, scalar field B is given in terms of x, y, z. So to find the Laplacian, it's a Cartesian coordinate system, right? We have to take the first derivative, okay? Then only we have to take the second derivative. So del square V, how can I write? This no V square, it is dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. That means dou by dou x of dou V by dou x. So first I will find dou V by dou x. That is, if I differentiate sine 2x, I will get 2 cos 2x. So that is the thing given here. Rest of the terms will not get affected. Plus dou by dou V y of dou V by dou y. Differentiation of V with respect to y is sine hy. Okay. For the last term, dou V by dou z. Okay. How will I find? It is e power minus z into minus 1. So minus e power minus z sine 2x into cos hy. So this is the first set of differentiation and derivation we have find. Now let us do the second derivative, perform the second derivative. So dou by dou x of this term, differentiation of cos is minus sine. So minus sine 2x into 2. So we'll get minus 4 e power minus 4, e power minus z sine 2x into cos hy plus if I differentiate with respect to y, e power minus z sine 2x will be there, it will be turned into cos hy. And here with respect to z, if I do, I will get minus e power minus z into minus 1. So minus minus turn out to be plus e power minus z sine 2x cos hy. If I see all the terms are having the same quantities, okay, same quantities but different magnitude. So if I do the summation minus 4 plus 1, what I get? Minus 4 plus 2 is minus 2 e power minus z sine 2x into cos hy. I hope you understood the different vector calculus, that is different vector differential operators like gradient, divergence in the previous session, now curl and Laplacian in this session. Thank you. Happy learning.